15 years ago, we had a revolution, and this is a phone. But back in the days, like poorly designed and very slow and hard to use. And then we got smartphones. This is the revolution we had. Now we are able to run applications, we're able to access to the internet, we can do pretty much whatever we want with smartphones. And I'm pretty sure that you wouldn't want to go back with old phones. Okay, now you are wondering, what is the link with Airflow? Actually, 2 months ago, we had a revolution. And yes, this revolution won't change your life, but it will change your way of managing and creating data pipelines in Airflow. And this is Airflow 2.0. My name is Marc Lamberti. I'm the head of customer training at Astronomer. And during the next 25 minutes, you are going to discover what are the new features of Airflow 2.0, why is this a massive improvement from Airflow 1.10.x, and why is this important for you? I think the best way to get started is to start with the feature that you will see as soon as you start Airflow, the user interface. And this is the user interface of Airflow 1.x. I'm pretty sure that you know this user interface, as we use it daily, but the problem is this user interface is not secure at all. Indeed, you have the data profiling tab, and if you access to the data profiling tab, well, you can access the data from your metadatabase, and that's definitely not something that you want. Indeed, if you use Airflow in production, you want to make sure that your user interface is secure. And more importantly, you are not able to create roles, permissions for your users. Actually, in Airflow 1, we had two user interfaces, and this one was the UI by default. In Airflow 2.0, it's over. Now there is only one user interface, and this user interface is this one. As you can see, it is definitely clearer and better designed than the previous one. More importantly, you can finally create roles and permissions along your users. So if you use Airflow in production, you have to go with the ORBAC UI in order to create the permissions and the roles you need for your users. Another important feature was the auto refresh. I'm pretty sure that you have triggered a DAG and you were on the graph view waiting for your tasks to be done by manually refreshing the page. And this is really boring. Instead, one of the most expected feature is the auto refresh button. Now, from the graph view, you can just trigger your DAG and see your tasks getting triggered one after the other thanks to the auto refresh button. So really, this is a small change, but game changing. So now we have seen the user interface along with the auto refresh button that we were really expecting. But there is another feature that I think you are expecting, like at least since 2 years ago. And there is a good chance that you are expecting it as well, which is the API. This is the previous API. This is the API that you get from Airflow 1.10.x. Let's say that you want to interact with variables. You can't. Let's say that you want to retry diagrams. You can't do it. Let's imagine now that you want to build an application on top of Airflow to manage your users. You can do it as well. As you can see, the API in Airflow 1.10.x was really experimental. And this since like 2 years ago, I think. Now it's over. In Airflow 2.0, there is a new API, the stable REST API. And I can show you right now that this, from the documentation, is really different. It is a huge improvement over the experimental API. As you can see right now, the documentation is much more clear. You can clearly see all the endpoints you have, and actually you can pretty interact with whatever you can pretty much interact with all the components of Airflow, such as connections, variables, or diagrams, and more importantly, most of the endpoints have CRUD operations. So if you want to create a connection, if you want to read the connection, if you want to list the connections, if you want to delete a connection, for example, you can do it. And also, you are able to know exactly what the endpoint expects and what it produces. That's what you can see from the right. So really, like right now, if you want to interact with the API, please go to the documentation of Airflow after the talk, go to the documentation of Airflow and check the stable REST API. This is like a huge improvement over the previous API, really. Okay, so we've discovered the new UI as well as the stable API. What is the third component with which we interact the most in Airflow? And actually, as soon as you install Airflow for the first time, you will interact with that component. Well, this is the command line interface. And in Airflow 2.0, there is a new command line interface. The command line interface has been entirely redesigned. You know, the problem with the previous command line interface is that there were many commands, and it is still the case, but now they are better organized. And this is super important as you will use the command line interface pretty often. You know, for example, if you want to test your tasks, well, you will use the command line interface. So what are the kind of commands that you get from the new CLI? Well, first, if you want to interact with all your commands have been put into groups. And groups are the resources that you want to interact with. For example, you want to interact with the database. You will use AirflowDB in it. You want to interact with your tasks, you will use Airflow tasks and then the command you want to execute. And I strongly advise you, as a best practice, to always test your tasks with Airflow task test. And then if you want to interact with your users, you know how to do that. You use Airflow users and create or list and so on. So all of your commands have been grouped together in different groups. And the groups are the resources you want to interact with. There are some exceptions with the commands such as Airflow Web Server or Airflow Scheduler in order to start either the scheduler or the web server. Okay, so we've discovered the new user interface. We know that we have the stable REST API in order to execute requests and build applications on top of Airflow. And now we've discovered the new command line interface. Now I would like to move to now it's time to discover the massive improvement that will make you fall in love with Airflow 2.0. Really. This is the most important, incredible improvement of Airflow 2.0, and this is the scheduler. Before, if you use Airflow 1.10.x right now, I'm pretty sure that whenever you trigger a DAG, even a simple DAG, well, executing the tasks is pretty slow, and the problem is, as you will create tests, if it's not already the case, well, your tests will be executed in your CI/CD pipeline. And if you have integration tests in order to make sure that your DAGs are working as expected, well, those tests will take a lot of time. Well, guess what? In Airflow 2.0, in average, the scheduler is 10 times faster. So that means if you use the new scheduler, if you go with Airflow 2.0 and run a DAG, there is a good chance that you won't even be able to see the tasks being triggered as it is so fast right now. And this is super important because, for example, you have tight SLAs. Well, obviously this is required. Or you want to start thinking about micro batchings, with small schedule intervals. You might be able to do that with the new scheduler. And last but not least, obviously your tests will be much faster to execute. And so you will be able to push new DAGs faster as well. So this is a great improvement, definitely. But there is even better. Indeed, what about if the scheduler goes down? Well, this is the single point of failure in Airflow 1.10.x. If your scheduler goes down, you won't be able to trigger any more tasks. And this is critical. As you can imagine, and that might be your case right now, Airflow is a central piece of your data stack. So if the scheduler goes down and you are not able to execute any more tasks, well, obviously the data scientists or the data analysts or even the managers won't be able to get their data in time, which can cause you a lot of trouble. Again, this is over. With Airflow 2.0, the scheduler is highly available. What does it mean? It means that you can run as many schedulers as you want. For example, let's imagine that this scheduler goes down. Actually, that's okay, because you have two other schedulers running. And so you can continue, you can still trigger your tasks with the other schedulers. So that's why it is super important. If you use Airflow in production, you have to use Airflow 2.0. This is the most important feature, and this is required in order to have a resilient, reliable orchestrator. Right now, you are able to execute. Right now, you are able to have as many schedulers as you want. If one goes down, you still have the other schedulers in charge of scheduling your tasks. There are three benefits for that. First, zero downtime. So that means, again, if one scheduler goes down, you still have the others. Also, if you want to apply some updates to your schedulers, you can do that one at a time. So basically, you will shut down the first scheduler, then update it, and then you will run it again, then go to the second scheduler, shut it down, put your patch, and then run it again, and so on. So this is the rolling updates, and you can do this right now because the scheduler is highly available. And last but not least, now you are able to scale to the infinity. Basically, if you have thousands of tasks to execute, you can do that with Airflow. The only thing you need is to add a new machine with a new scheduler, or even a new machine with multiple schedulers, and you add more resources to your Airflow instance, which means you can execute as many tasks as you want. So again, this is super, super important. If you use Airflow in production, you have to make sure that you have at least multiple schedulers running at the same time. Right now, if you use Airflow 1.10.x, you have a single point of failure. Okay, so all the improvements we've discovered so far are related to Airflow itself, the structure of Airflow. But what about DAGs? What are the new features that make our DAGs better? I think there is one feature that probably everybody has ever used in Airflow, which is the sub-DAGs. Sub-DAGs are not recommended at all. You should avoid as much as possible sub-DAGs. Why? First, you can end up with deadlocks, which means at some point you might not be able to execute any more tasks in your Airflow instance, which is pretty bad, as you can imagine. Second, sub-DAGs are pretty complex. You have to create a new file with the Python function, and this Python function returns a DAG, so you have to instantiate a DAG, you have to take care of the schedule interval, also you have to import the sub-DAG operator, then call the Python function, you have to make sure that the DAG ID of the sub-DAG is the one expected, there is a special notation. I mean, so much complexity just to group tasks together. It is overcomplicated. And also, they have their own executor. So basically, if you use Airflow right now with the local executor and you have some sub-DAGs, actually those sub-DAGs are using the sequential executor. I think it is the executor set by default to avoid some inconsistent behaviors. Okay, so there are many reasons of why you should not use sub-DAGs. And if you are using sub-DAGs inside sub-DAGs, it is even worse. Okay, so please avoid doing this. Okay, now you might say, thank you, Marc. We should not use sub-DAGs, but what should we use instead? You should use task groups. Task groups is a new concept in Airflow 2.0, and they do exactly what the sub-DAGs do, but in a better and more efficient way. Let me show you this. This is the only thing you need in order to group your tasks together. That's it. No need to import a sub-DAG operator, no need to create a new Python function, no need to instantiate a DAG and take care of the schedule interval and the default arguments and everything. No, you don't need that. The only thing you need is to import the task group, then instantiate a task group with an ID and put your tasks under that task group. That's it. It is more efficient, faster to implement, there is no risk of deadlocks, and you can even create groups of groups without, having weird behaviors and so on. So this is definitely easier to implement, and you should use task groups. You have to use task groups instead of sub-DAGs. In my opinion, right now, but I might be wrong, there is no real reasons to continue to use sub-DAGs instead of task groups. Task groups group your tasks, and that's what you want. Sub-DAGs are way more complex only for grouping tasks together. So go with task groups. Okay, so sub-DAGs were time-consuming and complex to understand. But there is another thing that we do over and over again, creating DAGs. Airflow 2.0 introduces a new way of creating DAGs and Python tasks, which is the TaskFlow API. Again, I strongly believe that an image was 1,000 words. So let me show you this. This is a DAG with the TaskFlow API. So what do you need to instantiate a DAG, to create a DAG with the TaskFlow API? Well, first, you need two decorators, DAG and task. In order to instantiate a DAG with the TaskFlow API, you just need to use the DAG. You just need to use the DAG decorator. As you can see right there, then you specify some parameters, the start date, the schedule interval, the catch-up parameter, as usual, the same parameters, but in the DAG decorator. And then you define a Python function corresponding to your DAG. So process_DAG here is the DAG ID, and it is your DAG that you will have if you instantiate a DAG object. Next, and this is really important, and this is really amazing, if you want to create a task, for example, if you want to create a Python operator, what you will do? Usually you import the Python operator, and then you implement the Python operator in the DAG object, and then you create a Python function outside of the DAG object, and in a better way, in another file, in another Python file. Well, it is pretty long to do that, and the Python operator is the most widely used operator. So definitely, if there is a easiest and fastest way to implement the Python operator, that could be much better. Well, this is exactly what does the task decorator. With the task decorator, you only need to create a Python function just below the decorator, and this Python function becomes automatically a Python operator with the function that you want to execute. So in that case here, def extract will become a Python operator executing extract. So it is much faster for creating Python operator tasks. And last but not least, what you can see below is the dependencies set with the TaskFlow API. When you share data between your tasks, you will use XCOMs to do that. But the problem with XCOMs is that they create implicit dependencies between your tasks. Indeed, you have to take a look into your code and even into your Python functions to know if that Python function exports or creates XCOM, and then you have to take a look at the other Python function to know if that XCOM is used in it. It creates implicit dependencies that can be pretty hard to manage if you have hundreds of tasks. Well, with the TaskFlow API, you can define, and actually if you use the task decorator, you can define your dependencies exactly like what you can see below, what you can see from below. So for example, let's say extract data produces some data that you want to process. Well, you create an XCOM and you put your data into that XCOM. Then the task process will automatically take the data produced from extract and will process the data. And you can clearly see the dependency from the functions below, with extract data calling first and then process data having the function extract data, having the function extract in the parameter of the function process. Okay. And as a best practice, don't forget don't use XCOMs to share big data, okay? XCOMs are limited in size, so be careful with XCOMs. So that's it about the TaskFlow API. So the TaskFlow API is really useful if you want to create, your DAGs in a little bit faster way. And also if you have many Python operators, you should definitely use the decorator, the task decorator. It will make your life easier and your DAG will become clearer. This is super important. You will end up with many, many tasks. So you have to make sure that your DAGs are as clear as possible. Okay, so the TaskFlow API is super interesting. I mean, we can definitely change the way of creating DAGs, but there is one other feature that you use a lot. The Python operator is one of the most widely used operator, but there is another kind of operator that you use a lot, the sensors. And the problem with the sensors is that they are kind of dumb, I would say. Let me explain. In Airflow 2.0, there is a new kind of sensors, the smart sensors. What I mean by the fact that the previous sensors were dumb? Well, they are not really dumb, but the thing is, a sensor waits for something to happen before moving to the next task. And the problem is, if you have hundreds of sensors waiting for something, they take worker slots. And the problem is you can end up with deadlocks as well. If you don't have any more worker slots, you won't be able to execute any more tasks, which is a big issue. And as the sensors are waiting for something, if the something doesn't show up, well, they will wait indefinitely, unless you've put a timeout. Also, it can happen that you have multiple sensors from multiple different DAGs waiting for the same thing. And since they are waiting for the same thing, well, you have kind of duplicates, you have some duplicates, and you don't want to have duplicates because you are wasting resources, okay? And last but not least, sensors produce heartbeats. So if you have many sensors, again, you will create a lot of requests against your database, and you should take care of your database. So this is why the smart sensors have been introduced. How they work? Well, you will have, instead of having one sensor executed at a time, your sensors will be executed in batches, where the sensors having the same kind of context, for example, sharing the same schedule, sharing the same interval, or waiting for the same thing, they will be put inside the same smart sensor operator. They will be put into the same group. And then, at a given interval of time, your sensors will be checked in batches. Okay, and so this is definitely more optimized because you are avoiding resources. You avoid wasting resources that you are paying for, because right now the sensors won't take worker slots indefinitely until they are done. You will just have a bunch of workers. You will just have some smart sensors being executed at a given interval of time, and they avoid duplicates. If you have some sensors that are duplicates, so waiting for the same thing, for example, you won't have a duplicate. You will end up with only one sensor managing all the sensors that are duplicates. And last but not least, it reduces the number of heartbeats. Obviously, as you will end up with less sensors, you will make less requests to the metastore. And this is, again, super important. You have to take care of your database. So smart sensors are extremely powerful, extremely powerful. And you should use them if you have like hundreds of sensors. Because I know what you can say right now. You can say, actually, with the sensor, I can use the reschedule mode. And this works. But if you have, again, you have to think about like what will happen if you have hundreds of sensors, which can be your case at some point. Well, even with the POC method reschedule, you will end up with some troubles. Okay, you might end up with deadlocks as well. So that's why smart sensors are really useful if you have hundreds of sensors that are running in your Airflow instance right now. Now I would like to talk. Now we know about sensors, the TaskFlow API, and the task groups, there is one last thing super important. And there is a good chance that you use right now the Kubernetes executor. And I would like to talk about Kubernetes. In Airflow 2.0, the Kubernetes executor has been entirely redesigned. And more importantly, there is a new executor config allowing you to overwrite your pods. And instead of, basically right now with Airflow 1.10.x, if you want to, if you use the executor config, actually you will be limited. You have this dictionary, and you can only customize what the dictionary allows you to customize. This is not the case anymore in Airflow 2.0. With the new executor config, you can fully use the Kubernetes API. And so as long as you know Kubernetes, which is a beast, you are able to customize your pods as much as you want. So if you use Kubernetes, this is super important. Okay, because you might want to specifically modify things for a specific task. You might want to specifically override a pod for a specific task. And you can do that with the executor config without any limitations. That's the difference with Airflow 1 and Airflow 2. Airflow 2.0 is a massive improvement. Airflow 2.0 is a massive improvement from Airflow 1.10.x. If your goal is to have a reliable, efficient, and fast orchestrator, you have to use Airflow 2.0. If you want to optimize your resources and execute as many tasks as you want, you have to use Airflow 2.0. If you want to create DAGs that are better designed and with new functionalities such as task groups, the TaskFlow API, and the smart sensors, you have to use Airflow 2.0. You have to use Airflow 2.0. 2 months ago, I updated from Airflow 1.10.x to Airflow 2.0. And like with smartphones, I will never go back. So upgrade to Airflow 2.0. Thank you, everyone.